Okay, so we're doing example 2 on page 183. So it says determine the coordinates of all points on the unit circle that satisfy the given conditions. So the x coordinate is 2/3. So before I started recording this, I said the formula for the unit circle is x squared plus y squared equals 1 squared. Okay, so that's what we're going to use to find the coordinates that we need, because for coordinates you need an x and you need a y. Okay, so we're given the x coordinate is 2/3. So we can plug that in by going 2/3 squared plus y squared is equal to 1 squared. Okay, so 2/3 squared, that just means 2 times 2 is 4, 3 times 3 is 9, plus y squared is still equal to 1 times 1 is 1. Okay, so we want to get y by itself. So we'll subtract the 4/9 over here and we'll subtract it on this side. And what I do is, because this is 1, I always just make it so it has the same denominator. So 1 is the same thing as 9 over 9. No, because 1 squared is 1. So, yeah. So he's no longer squared. Okay, so the easiest thing is to change that 1 into whatever your bottom is. Yeah, so we have y squared is equal to, so 9 minus 4 is 5, and you leave the denominators. And we still want to know what y is. So we square root, and whenever we square root, we bring in a plus minus. Okay, so our y, sorry, I'll root that to get rid of that. So our y is plus or minus root 5, and the root of 9 is 3. Okay, so our coordinate is, if our x's are 2/3, so we'll write it as 2/3, and a root 5 over 3, and we have to write the second point of 2/3 and a minus root 5 over 3. Okay, so we'll cruise to example 3 because this one for B is done exactly the same way, except this is your y, and you just solve for your x. Okay, so we'll move to example 3. And this we can use because we just built a unit circle in class. So we can get out our unit circle and we can find the information we need to answer this, okay? So it says, on a diagram of the unit circle, show the integral multiples of pi over 3. Okay, so all you're doing is, say this is our unit circle that we drew. We are following the ones that match with pi over 3. So remember on your unit circle, pi over 3 was here, right? Okay, so it would help me if I had a picture of the unit circle, but the other one that matches that guy would be here, 2 pi over 3. Okay, and then you draw the reflecting ones here and there. I mean, you don't need to draw them because you have them on your unit circle. And so that one is, think of this as 3 pi over 3, so that's 1 pi. This one is 4 pi over 3, 5 pi over 3. And then this one should be 5 pi over 3. Okay, so those are the ones I'm referring to, just the pi over 3 ones. So if you look on your unit circle, if we're going for the from 0 all the way to 2 pi, so we'd be counting 0, we'd be counting this guy, we'd be counting this guy, we would count this one, and we would count this one, and then when we get to here, to 2 pi. Okay, and when I was going around, I forgot to include this guy, he counts 2, okay? So when we were going by thirds, we counted 1/3, we started at 0 and we went 1/3, 2/3, 3/3 is 1 pi, 4/3, 5/3, and 6/3 is 2 pi, okay? So those are all the guys that count for this. So for A, you could just list them out if you wanted. Okay, so that's them all listed out. And then if I said, what are the coordinates for each of those points? You have the coordinates on your unit circle, right? Like the coordinates are a half, comma, root 3 over 2 for the first one, okay? So I'm not going to write them all out. Do you always start at 0? Is that what you said? Yeah, we'll include it, yeah. So the point for him is 1 and 0, right? This one is 1 and 0. This guy is a half and root 3 over 2. And then we just keep going. Okay, so we have that information on our unit circle.